Let's learn about core concepts of probability, like random variable, standard deviation, mean. Let's learn about core concepts of probability, like random variable, standard deviation, variance, mean. These are used everywhere. When it comes to AI and machine learning, it's used in diffusion models, large language models, reinforcement learning, flow matching, everywhere. And it's also used in economics, finance, math, physics, everywhere. And this is extremely important, and everybody who's good at their profession will master this one. Let's say we are flipping a coin and we can get heads or tails. How do we calculate the probability? If we flip it 6 times, how many times we will get heads? This is important in large language models, especially in video generation, image generation, flow matching, diffusion, everywhere. So we will use a random variable to turn these heads and tails into some math notations. So we can decide that if the outcome is heads, then we will assign 1 to our random variable. If the outcome is tails, we will assign 0. So this is how we just decide to assign, so we can translate heads and tails into actual math, and we can do math with it. So the value of x is not known in the beginning. That's why it's called random variable. We don't know it until we get results from flipping the coin. So the x has a 50% chance to be 1 and 50% chance to be 0. It's not known beforehand. So we can say that probability of random variable x being 1 or being heads is 0.5 or 50%. And probability of random variable x being 0 is also 0.5, 50%. Now, given these two probabilities, what is the expected value for this variable, which is like a center of or average value? You can actually get this center of mass or expected value by just flipping the coin many times. So if we flip it 100 times, we would expect 50 heads and 50 tails, because the probabilities are 50% and 50%. To calculate now the average value, we just multiply 50 times 1 plus 50 times 0, which is gonna be 50 in total. And the average will be divided by the number of total flips, which is 100. So sum divided by the number of flips, which is going to be 0.5. So this is the intuitive way to calculate the average value. If we have 50% chance of getting 1 and 50% chance of getting 0, that's the intuitive. 0.5 is the average value. But instead of imagining we flip it 100 times, we can do it directly with weighted average. And it's very simple. For each of the outcomes, so x equals 1 and x equals 0, we multiply that outcome with its probability. 1 times 0.5 and 0 times 0.5. And then we just sum them up. So in this simpler way, we can get the exact same average or center of mass of all of the probabilities and possibilities. And we can put this into a general formula here. So event, which is going to be either 0, 1, 2, 3, whatever the event, whatever the number that we represent the event as, times probability of that random variable being that event. So just of the probability of that event happening. And then we sum all of those for every one, just as we did here. And that's the center of mass, the average value, the expected value. But this is important. Even though expected value is 0.5, it doesn't mean that we will ever get this value. So expected value doesn't have to be possible at all. The expected value does not have to be a possible outcome. It's just a theoretical average of all of the outcomes. Let's see another example. Let's say you have a dice with 6 sides. What is the average value you're gonna get? So the numbers you can get are 1, 2, 3, 4, 5, 6. And given that every side has equal probability of being flipped, then it's very simple. You just multiply each of these numbers with its probability, which is 1.1 over 6. And then add all of them up, which you can first add the numbers and then divide by 6. This is just associativity. And then the expected value is 3.5. So even though it's not possible to get this number, this is the average value if you will get. Let's take a look at the expected value a bit deeper. So let's see, we have two different games. One is you flip a coin, and if it's heads, you get $1. If it's tails, you get nothing. And we already know that the expected value here is $0.5, so you are expected to get 0.5 every round on average. Now let's look at the similar bet, where if you win a coin flip, you get $100. If you lose coin flip, you lose $99. So if you calculate here, the expected value will actually be same. On average, you will win $0.50 every round. But this second bet feels a lot scarier. This is very safe, you don't lose anything or you win $1, but this is very scary. What if I lose a few times in a row, then I don't have any more money to bet? So how can we define this risk factor or spread of this second bet? So we can also put that into our math. We will use variance and standard deviation to calculate the spread. So look at these graphs. Both of these curves have the mean in the middle. It's like $0.5, our mean value, but the spread is very different. The core question this spread answers is how far away on average are the outcomes from the expected value? Are they tightly clustered together around the center, or are they all over the place? So in the first bet, usually I would just, if the middle expected value is 0.5, I would either go to 0 or 1 or 0 or 1. But in the second bet, I would go like minus 99, 100, minus 99, 100, minus, so it's a lot more spread out. The first idea would be to just measure. For example, I know the average is 0.5 and I can get 0 or 1. So if x is 1, if we win the bet, then we get plus 0.5. If we lose minus 0.5. So there's the distance. So plus 0.5 is distance on this and minus 0.5 distance on this from the mean. So if you try to calculate average distance from the mean by just adding these two up and dividing it by 2, you add them up, you divide by the 2. You will, when they add up, they're gonna give 0 because it's positive and negative. And then divide by 2, it's still 0. So 0 is a useless number. It doesn't show us the average distance from the mean. We can also use our strategy to multiply this distance with the probability of that event happening. So distance with the probability of that distance happening. And if we do that for both of them, again, we're gonna get 0, which is not, because we have this minus and it cancels out. So we need to measure the deviation or variance or distance by getting rid of this negative sign. A good way to get rid of this negative sign is to just square. So we square this one and this one, we square both of them. Here, this is where it's shown. So we just square these results to get 0.25 on both of them. So we will no longer get 0 as the average distance of these results from the mean. And we can intuitively see that if this is one distance from the mean and we get the same distance from the mean again, then the average of those two distances will be this same distance. So this is the actual distance from the mean because it's same both times. So this is what's going to happen every time then. Or in other words, we can also use our method of the weighted average. So we do square deviation, which is this is a square deviation, for the heads times probability of the heads happening plus square deviation of the tails times probability of tails happening, so we get 0.25 again. By now, you may think, why are we using this weighted average? Why are we multiplying each of the distances with the probability it happens? Why not just add up both of them, like 0.22, 0.22, and divide by 2 to get the average? It's because this only works if the probability of these two happening is equal. Then we can add them up and divide by 2. Let's see, we have some weird coin that has 80% chance of giving heads and 20% chance of giving tails. So it's 80% chance to be 1 and 20% chance to be 0. Let's calculate the mean or center of mass here. So 1 times 0.8 plus 0 times 0.2, 20%, we get 0.8 as the mean. And then we calculate square deviations in order to remove the negative sign, so they don't cancel out. So this is a square deviation, and it's not standard deviation, it's square deviation. Standard deviation is a bit different. Standard deviation is the average of square deviations for each of these, but we have square deviation for the x equals 1, which is this small number, and square deviation from x equals 2, which is this larger number, because the average is actually closer to 1. So the square deviation will be smaller. It's not going to deviate so much from average to 1. There is not so much deviation. And the simple averaging method gives us 0.34 if we add them up and divide by 2. So this is the average square deviation. But the weighted average will give us different result. And this one is actually correct. Because this square deviation will happen a lot more often. So we multiply it with a bigger number, give it higher weight. And this will happen less often. So that's why we want to do it like this. So this is the variance, the weighted average of square deviations. So we just got introduced into this new popular concept, variance. So it's just a weighted average of squared deviations that I just explained. And if you take a square root of the variance, you get standard deviation. So standard deviation is the square root of the variance. But let's go step by step. Let's get back. So the problem with this variance that I was explaining until now, when we are squaring things, the problem is if we are looking into our game of dollars, winning $1 or $0, then if I'm trying to calculate the variance, my measure would be in dollars squared. So I would be $0.25 squared away from the mean, which is a bit weird. So we use more interpretable measure, standard deviation, that I just mentioned. So we just take the square root of the variance to get the standard deviation. So square root of 0.25 is 0.5. So in our case of $1 or $0, each of them is exactly one standard deviation, which is 0.5, so one standard deviation away from mean. It's in this simple example, doesn't have to happen at all the time. So variance is an average of square distances from the mean for every data point. So average of square distances from the mean for every data point. And standard deviation, when we take the square root of the variance, we get typical distance from mean for all of the data points. So a low standard deviation on this purple-pink curve means that data points are more clustered around the mean. And higher standard deviation means data points are more spread out around mean. That's it for this video. Join my school to become AI researcher. We have all of these free courses. It's free for now, but I'm gonna make it paid, so hurry up. Link below the video.